Hi, my name is Anand, and in this video I'm going to give you a quick demo of the deployment milestone for a software engineering project. As you can see, I've just created a new VM on DigitalOcean, and the deployment of our application is based on Docker containers. We've divided our application into three simple subcomponents, and each of these subcomponents would be deployed as individual Docker containers, and the whole Docker container setup is run on a VM, in this case the VM that I just created. The first step of our deployment essentially consists of setting up this VM so that it can run Docker commands and essentially install all the prerequisites to run our application. For that, we've created a Ansible playbook, which, for example, installs Docker Compose, and then pulls the latest code and sets a whole bunch of API tokens, etc., as environment variables that are needed for the actual deployment using Docker to work. So let me just show you the first component, which is the Ansible playbook. So I'm just going to update my inventory file with the latest IP address that I just got of the new VM. And let me go ahead and run the playbook. This usually takes a couple of minutes, but and the end result will be that we have all these subcomponents installed and we have a VM that is up and ready to run our latest code. As you can also see, as you can see, the first few steps involve installing the software that is required, essentially Docker, Docker Compose, Git, etc. And towards the later part of the playbook, you can see that we're pulling the latest code from the GitHub repo. And we're also setting a whole bunch of environment variables so that the Docker Compose application that is deployed using Docker Compose can use this from within the VM. We've made sure that we haven't included any of these API tokens in the code for the sake of safety and security. Looks like the Ansible playbook is successfully completed. Let me just log into this VM and show you that the operations have actually been completed. As you can see, the InfraRed folder has been created, which has been pulled from Git. Let me just go inside this. As you can see, inside our InfraRed folder, we have a docker compose.yml file. I have it open right here. And this docker compose.yml file essentially defines the set of containers that need to be spun up for the entire application to function. In our case, the application is broken down to three different subcomponents. To give you a quick overview, we have the application container, which is actually running the Node.js bot implementation, which talks to the Slack servers and the API.ai servers. And also the other container that we have is the provisioning server, which essentially communicates with AWS and DigitalOcean to spin up new VMs as per the user's request. And to save the state of our application, we use a MongoDB container. And all three of these containers are orchestrated using Docker Compose. And all three of these containers are also sandboxed within a network that is managed by Docker. And the only outside communication is really with Slack, API.ai, and the cloud providers. As you can see, we have defined the deployment strategies for our three different components. The bot, which as here we're defining that we need the bot container to build using the Docker file that is defined in bot_api.ai folder. To give you a quick example, this Docker file essentially defines the image that needs to be created upon which the container will be built. By defining the exact image, we're able to recreate the exact same running conditions even upon relaunch of the application. Also, we're defining the links that are required. Here we are saying that the bot needs to talk to the provisioning container, and we're also using a bunch of environment variables that we have set using the Ansible playbook. Similarly, the provisioning container is built using the Docker file in the provisioning service, and similarly, we're setting up links between the database and the provisioning server. Let me quickly run Docker Compose and demonstrate this for you. So the first step would be to actually build the images using Docker Compose build. The build process essentially creates images that can be used as base images for creating containers. In this case, we would be creating two different images out of bot and provisioning service. The DB is different because here we say that we're directly defining a predefined image called Mongo version 3.2.11, which it would pull from the internet. This process usually takes a couple of minutes. Although the build process might take quite a while, running new containers using the images that are already built happens almost instantaneously. Therefore, we never need to pay the penalty of building the time penalty associated with building new images whenever application container goes down, or if we wanted to restart a particular set of containers. Looks like the build process is completed. As you can see, it has created two new images called InfraRed bot and InfraRed provision, which are essentially going to be the base images for our containers running the bot and our provisioning service applications. Let me just do a Docker compose up, which would essentially create containers defined in the Docker compose file, namely the bot, the provisioning service, and the database. Also, as you can see right now, our InfraRed bot is offline, and once the deployment is complete, we should ideally see this going online. As you can see, slowly our containers are being deployed, and we've already seen the logs starting to flow in from the database server and the provisioning server, and also our from a bot container. And if we look at Slack, we can see that the InfraRed bot has actually gone online. And as we type commands here, we should see logs flowing into the terminal right beside it. As you can see, the bot is functioning. We have quickly demonstrated the actual deployment of our entire application and the infrastructure associated with it. That completes our demo for today. Thank you.